So this is lesson 21, 0 and negative exponents. So we're going to talk about exponents. Exponents have to do with multiplication in math, okay? And it's just another way to write multiplication problems. Okay, we don't always use exponents. We use exponents when we want to multiply the same thing over and over again, okay? So like a problem like this one, 2 times 3. What's 2 times 3? 6, right? Am I multiplying the same thing over and over again to get 6? No. So we're not using an exponent here. But what if I was multiplying 2 times 2? 2 times 2 is? 4, right? Well, another way we could write it is 2 squared, right? 2 squared is the same thing as 2 times 2. When we see an exponent of 2 to the second power, we're saying this is like 2 times 2. It's the same answer, right? Which way is easier to write, 2 times 2 or 2 squared? 2 squared, okay. Anyone disagree with that? Anyone think it's easier to go 2 times 2? Raise your hand if you believe that. Okay. Why are we writing exponents? Why would they write exponents? Can someone give me a reason why they invented this way of writing it? Yeah.
To make it quicker so you don't waste time on writing out the problem.
Exactly. We don't want to waste time writing out the problem because, right, what does Mr. Rink ask? What are the 3 things when you do your homework? Write the original problem, show your work, and get the right answer. Box your answer, right? Does that make sense? So if I were to give you a problem that looked like this, 2 times 2 times 2 times 2 times 2 times 2 times 2, wouldn't you get really mad at me?
Yeah.
Right? And I said, show all your work, right? Wouldn't that get annoying after a while? So we use these things called exponents. So we could rewrite this. There are 8 2's being multiplied together. So the way we could write this is 2 to the 8th power. Isn't that easier than writing 2 8 times, right? And of course, we multiply this out, you get 256, okay? If I were to multiply it out. Oh, going so fast here. I don't know what's going on here. Here we go. So the answer is 256. So again, exponents make it easier to write multiply problems, okay? So here are the steps. You guys write the steps down yet? Yep? Okay, good. So identify the exponential property and then apply the property appropriately. You were supposed to learn exponents way back in 7th grade pre-algebra, okay? If you didn't, then let's relearn them. If you know them, let's just reaffirm what you know. So here are all the exponent properties. You're going to know all of these, okay? But today on the lesson, we're only going to focus on the top 3. So I'm going to erase the bottom, okay? So we're supposed to know all of this, but all we're really going to know is the top 3, okay? So start writing these down, and I'm going to explain them. Okay, so just as a review, exponent review, a to the 0 power. I want to let you know anything to the 0 power is 1, okay? Anything to the 0 power is 1. Turn to your neighbor and say anything to the 0 power is 1. Okay, good. That means 1 billion to the 0 power is 1. 0 to the 0 power is 1. Negative 1 trillion to the 0 power is 1. No, it's 1. Because remember, anything to the 0 power is 1. So negative 1 trillion is 1. Good. Y'all got that? Okay. Yes. No, to the 0 power is 1. That's different. 0 times anything is 0. But we're talking about anything to the 0 power is 1. Okay. You'll learn why in algebra too, but for now just know. Anything to the 0 power is? What's negative 1 billion to the 0 power? 1. Positive 1. Okay, good. Next one is this negative n power. We don't like negative powers in math, so what we do, watch up here before you write it down, is we need to look at anything as a fraction. Whenever we want to make anything a fraction, we can put it over 1, okay? In order to get rid of a negative power, we take the base with that negative power and we just move it to the opposite side of the fraction. So if it's in the numerator, we're going to move it to the denominator. If it's in the denominator, we're going to put it in the numerator. So watch. This is in the numerator. It's a negative power, so we're going to take the base and the power and put it in the denominator. Okay? All we're left with in the numerator is 1. Okay? Does that make sense? Okay? So, turn to your neighbor, explain how we get rid of negative exponents within a fraction. Okay, good. So write that down, please. Write that down. The second one. Okay. So let me show you one more example with this negative exponent. What if you had an exponent look like this? Okay. Let's say this was your problem. You see right here, x to the negative first. Is it in the numerator or denominator? Okay. Does it have a negative exponent? Yeah, it does. But does y squared have a negative exponent? No. So we only worry about the x, right? Because this is the only thing that has a negative exponent. We don't like that, so we just move it to the opposite end. This one has it in the denominator, and it's only x, so we're only going to worry about the x. We're going to move that to the numerator, x to the first, and the denominator is just going to have y squared. Okay? You'll see that? You can write that example too. I want you to see that. Oh, thank you. Oh. Okay. Yeah, what's up?
Why do you put the x on top?
Because what kind of exponent did it start with?
Oh.
Do we like negative exponents?
Yeah,
Yeah. So we just move it at the top. So we always move it to the opposite side. Okay? You see this one, this was in the numerator, so we're putting it in the denominator. Right? Okay, last one, a to the first power. Anything to the first power is itself. Okay? Anything to the first power is itself. Turn to your neighbor and say, anything to the first power is itself. Okay, good. That means 1 billion to the first power is?
1 billion.
Good. Negative 1 trillion to the first power is?
Negative 1 trillion.
Negative 1 trillion to the 0 power is?
1.
Good. Okay. Which means, if I were to say Marky to the first power is? Marky. Good. It's just himself, right? The opposite is also true. Marky has an imaginary first power next to him, always.
It's my backpack.
No. There's an imaginary first power with him, right? So we could always assume any of these letters have an imaginary first power by them. So even this A right here, you see, if I were just presented with A by itself and no first power, we could just assume A is equal to, has a little first power above it, okay? Do you all get that?
Yes.
The same thing with numbers. Let's say I had the number 2, okay? 2 has an imaginary first power next to it. We don't put it in there in math because it's redundant, okay? Right? Just like I'm not going to say, hey, Marky to the first power. What's up, buddy? Am I going to say, hey, Marky? Yeah, are we going to say that to everyone? What's up, Angel to the first power? Isn't that kind of annoying, right? So do we need to say that? No. Okay? All right, so let's start the lesson. Here we go. So I want to show you a couple of examples. So eyes up here first before you start working. And then after I'm done showing you, you're going to talk to your neighbor about it, and then you're going to write. So no writing right now. I need you to watch because it's really important that you watch. Okay? So we got 2 to the negative second power. I know from my properties that I don't like negative powers. And I also know that I can make anything a fraction by putting it over 1. Okay? So that negative power I don't like, so how do I get rid of it? I take the base of 2, and I put it into the denominator. We got 2 squared, okay? And then we have 1, right? 1 over 2 squared. Now I can multiply. 2 squared is like saying 2 times 2. What's 2 times 2? 4, okay? So I'm going to multiply it out, okay? And that's it. So 1/4 is my first answer, okay? That's all I did. Okay, number 2. 3 to the 0 power. I know my properties. Anything to the 0 power is 1. Anything to the 0 power is 1, so I'm going to just write down 1. That's an easy answer. Okay? Oh, sorry about that. There you go. Numbers 1 and 2. Raise your hand if you have any questions on numbers 1 and 2 before you start talking. Yes. No one's writing or talking yet.
For like number 1, how it says like 1 over 4, Robinson, would you write like the answer just 4? Would it be wrong?
It's wrong. What would you want? 1/4 pizza or 4 pizzas? Right? They're different, right? Is 1/4 pizza the same as 4 pizzas? No. So if you put 4, is it wrong? Yes. Totally different numbers. What's up? Because that's not the same. Is the answer 4? No. Did you get that? Okay. You got it, Omar? You sure? I don't want you to tell your neighbor the wrong thing. Okay. You guys got it? Okay, cool. All right, so let's have one solo 2's about number 1, and then 2 solo 1's about number 2. Ready, set, go. So number 3 is on the board, x to the negative third power. I want you to think about what property you're going to use, and then write your answer and box it, and then show your neighbor just to make sure you guys get the right answer. Okay, go. I'll give you 30 seconds. Again, the answer is 1 over x cubed, right? Because we don't like that negative sign, we're going to leave it alone. Can I multiply x times x times x? Do I know how to do that? Do we know what the variable x times x times x is? No, so we just leave it as x cubed, okay? Make sense? So that's it. Number 4. Be very careful when you do number 4. It's very similar to 3, but it's not exactly the same. Look back at your notes on the properties, okay? Go. Okay, so number 4, we got x to the negative third, y to the fourth. Remember, we can make anything a fraction by putting over 1. Don't erase your boards yet, because, you know, I didn't say you did it right. Some of you did it wrong, okay? I never say who did it right, because I want you to check your work. So we got x to the negative third, y to the fourth. We can put it all over 1, okay? So we don't like this negative exponent. We're going to put it into the denominator. But what about y to the fourth? Does y to the fourth move to the denominator? No, it does not, because it doesn't have an exponent, or negative exponent, okay? So we keep that in the numerator. The denominator is getting x to the third power, okay? So that's your answer. If you made a mistake, please fix it, okay? Raise your hand if you made a silly mistake. You can put x and y, you reverse them on accident. Okay, so if you made a mistake, I'd like you to discuss with your neighbor what you did wrong and explain how you're going to do it correctly next time. Ready, set, go. Set, go. 2 to the first. Does it have a negative exponent? Yes or no? No. So do I need to move it to the denominator? No. And I'm putting a 1, right, because we know we're always dealing in fractions here. M to the 0 is 1, right? So I could really write 2, bring 2 across, and I could change m to the 0 to 1, right? And we know there's a multiply sign in between them, right, as imaginary. So I'm just going to put that there also. N to the negative third. Do we like that negative third power? No, we don't. So we need to just take that negative third and the n and bring it to the denominator like so and make it positive. You see that? Okay. Am I done? Can we simplify anymore?
Yes.
Yeah, what's 2 times 1?
2.
2. And then n to the third, we just leave it alone. That's your answer. Okay? Does that make sense? Okay, so any questions on this one? Yes?
There's always going to be a multiplication sign.
Yeah, in between numbers and letters, there's an imaginary multiplication sign. Good question. Did y'all hear his question? He asked, is there going to be a multiplication sign between numbers and letters? Yes. Always. Okay, raise your hand if you made a mistake. Don't go to 6 yet. We're not ready for 6. Raise your hand if you made a mistake. Okay, reflect on it. Think about it. Turn to your neighbor. Explain what you did wrong and how you're going to fix it next time. Ready, set, go. We're not doing number 6 yet. Okay, last one. Again, we got x to the negative first, y to the 0. Work really slowly. We know this is a big fraction, right? So we can put over 1. That x to the negative first, do we like that? No, we got to bring that to the bottom. So we're writing down x to the first. Now y to the 0, anything the 0 power is?
1.
Anything the 0 power is? 1. Get it right. It's not 0, it's 1. So we're going to bring that across as 1. And then, of course, anything to the first power is?
1.
Is itself. Anything in the first power is itself. Okay? That's your answer. Right? Raise your hand if you made a mistake on this last one. Even if it was a silly mistake. Okay. Think about where you made a mistake and how you could fix it next time. What?
How'd you get the x?
What, here? At the end?
How'd you lose the 1?
Anything to the first power is? Itself. No. Anything to the first power is itself. What's Mike to the first power? Mike, right? Right? So, am I going to call you, hey, what's up, Mike, to the first power? Just like I was like, what's up, Mark, to the first power? Are we going to do that? No, that's kind of silly, right? So, with same thing, we don't say x to the first power. We just leave it as x. Okay? Does that make sense? Give me a thumbs up, thumbs to the side, thumbs down on how you felt about this lesson. Okay? That's all right. We're going to have some practice. That concludes this lesson. So, please turn to your neighbor to discuss these